Right, welcome back. Our next presentation is from Laurie Caligaris and Miran Pereira from Toray, and they're going to talk to us about their CFRT material. Laurie, over to you.
Yeah, thank you, John. Hey, good morning, everybody, or good afternoon, whatever time zone that you're on. I'm Laurie Caligaris. I'm in charge of the commercial part of our business here at Toray Performance Materials Corporation. And with me today, we have Miran Pereira, who's been with our company more than 30 years, and in the composites business, many, many more years. Miran has spent a lot of time at customers and working in our applications and really helping customers with their design and with the particular application all the way through the process, really cradle to grave. So super excited to have Miran here with me today. It'll be available for all the questions at the end there.
Thank you all.
Miran and I have worked together a long time, so we may finish each other's sentences here.
That's scary.
So we're going to talk to you today about our CFRT materials. That's continuous fiber reinforced thermoplastics. And we have been in this business for a long time. We were pioneers early on, and we have found that the benefits of the CFRT, their high volume manufacturing, the cost to performance ratio, and just the aesthetic benefits as well that you're able to, provide for those particular applications has been one that's been extremely beneficial for our customers. Oh, and before I forget, we do have something for you if you're interested and want to send your information over to us. We have our Ortho Golfer product, which is a completely packaged product. It's an insole that's used for training in golf. And so if you want to send your size, your name, your company over to us, we will help you with that. All right. Okay. So let's talk a moment about carbon fiber, vertical integration, and the strength of Toray. Our division was only acquired a few years ago, and it's been a real eye-opener to us to watch this global conglomerate around the world. Toray is the largest supplier of carbon fiber on Earth. We produce vertically integrated globally. So this has been a real advantage specifically during COVID. It's the ultimate supply chain security to have the ability to manufacture in Asia, the US, and in Europe. So what exactly is carbon fiber in a composite? So to understand our materials, we first have to understand this concept. Webster's dictionary has defined a composite as a solid material which is composed of two or more substances having different physical characteristics in which each substance retains its identity while contributing desirable properties to the whole. So composites can be found in many areas of our life: aerospace, athletic equipment, vehicles, motorsports, boats, military, high-end tech, construction, medical. I could go on and on and on. And composites are used to reduce weight. This is because there's a high strength to weight ratio compared to the homogeneous materials. One example would be an aircraft where fuel savings is up to 20%, can be achieved with 50% of the aircraft being made from composite materials. This is a common pyramid that many of you may have seen before. This pyramid basically lays out the world of polymers we work in. You can see at the very top are the high temperature polymers, our division at Morgan Hill, Toray Advanced Composites works within. This is normally used for highly engineered aerospace applications. And if that's something that you're looking for, we're more than happy to connect you with our colleagues at that division. We work predominantly in the bottom half of the pyramid in the applications that we manufacture. And when we talk about these engineered thermoplastics, keep in mind, we can create a hybrid of materials by combining the woven layers with the UD layers as polymers, are compatible. While giving the benefit of the UD efficiency, it offers the woven cosmetic so many of our customers desire. Here's a deeper dive into the polymers our division works with day in and day out. We offer these polymers in a number of carbon and glass options, as well as the hybrid options we discussed on that last slide. So with both woven carbon fiber and glass and unidirectional carbon fiber and glass, we're able to really blanket the entire world of industrial applications, encroaching upon those more highly engineered projects. The first one at the very top is the TC910, which is a nylon 6. We use this for battery covers, seat structural reinforcement, and the reinforcement of the parts are compatible with typical polymers used. So it's easy to injection over mold for a mechanical bond. The second one there is our TC925, which is a polycarbonate. It's used, for fire retardant applications. So think of computer electronics industry, aerospace, transportation, where that fire retardancy is highly desirable. And again, these parts are, compatible, so they can be used as reinforcement strategically along with injection molding and other compatible polymers. The TC940, this is our PET polymer with carbon and glass. And it's really become our workhorse of late. And it's just really the cost to the benefit ratio here on that particular polymer and construction. It's something that we're able to achieve multiple aesthetics as well. So our customers are latching on to this product because they can relate to the polymer in their water bottles and the potential for recyclability. The TC960 is our polypropylene. This polymer is best used for a high impact and chemical resistance. And it's one of the lightest resin systems that we work with. And last but not least is our PMMA TC950, which is an impact modified in-house formulated acrylic resin system. This is the polymer that launched our division back in the 1980s. And today we have produced in excess of 200 million parts in this resin system. Yes, 200 million parts. The polymer and woven combinations with carbon and glass allow us to pigment the resin and provide beautiful color options. And unlike the other polymers that we deal with, which are offered typically in black or natural, our customers enjoy the full Pantone ability with our PMMA resin. And if you're interested in any information on these polymers, the color combinations, or your specific application, of course, feel free to contact us after this presentation. Okay, because many of our customers are attempting to replace a part made from injection molding, which may or may not contain fibers or highly laborsome thermoset material, we're often asked about our CFR materials and how does it compare on that cost for performance trajectory. So beginning from the left, you see the short fiber thermoplastic, which is often made from injection molding, and then moving to long fiber, which is predominantly bulk molding compound. Then you see our CFRT materials and the thermoset composites, and they overlap there. So thermoplastics have really evolved where many of the applications once made from high performance thermoset composites can now be made from the CFRT. This is a breakdown comparison between our CFRT materials, thermoset composites, and then neat resin or non-reinforced plastics. And as you can see here, if you basically take, these are the I guess, attributes, if you will, that our customers are typically most interested in. So stiffness to weight, mechanical properties, tooling costs, which is huge for a lot of our customers, energy return, fabrication, and what can I do with it? So when we sit down with a customer, we have a huge toolbox that we can, this format, we can easily guide customers into the material that they're most comfortable with. Either it's completely performance driven, it could be price driven in some of the markets that we're in. And then many of them, there is a high level of cosmetic attribute that our customers are very, very concerned with. All right, so how do we do it? The first step is to make a flat sheet laminate. That's typically how we make most of what we do. Now, we do have other ways of manufacturing that we will also touch on, but most of what we do starts in a flat sheet. And the reason is because it's so efficient. You don't make millions of pairs per month by making one or two at a time. So we take that flat sheet and then we cut the parts by 2D with a water jet. And the parts are nested. As you can see, there's very good utilization. And what's left of that panel, if you can see that behind what this would be like a foot orthotic, okay, that's what's being nested out here. So in the background is what panel's left. And we're looking at ways to recycle that skeleton that's left over. All right, so from the water jet, you now have a 2D cut part. And these parts, again, are cut in seconds and literally producing millions per month. Now here's that same part formed, which we formed we can use vacuum forming. This one happened to be match metal tooling and compression molding. And these parts are formed net in seconds. So there's no post trimming needed. So this particular part happened to be used for a product that was going to be injection overmolded. So you can see the black there is the first shot on the inside. And the product also has a tie layer. So in this case, you see color, it's our PMMA acrylic resin system, but it has a TPU tie layer that the shot was able to bond without any harmful solvents, for cleaners or primers or adhesives. And there's the final product there. You can see the final shot's a clear TPU, and it's beautiful. Okay, here is another just few examples of our manufacturing. So in addition to match metal tooling, I talked a little bit about or mentioned compression molding. So this is a tape to part application. Literally just took our tape, rolled it up in somewhat of like a cigar shape, made an X, and through heat and pressure, you see the part at the top right there. Highly definition part. Again, no post trimming, made to net, and the consistency was incredible. The way the polymer flowed through heat and pressure, when on a burn off, those fibers were oriented almost the same, every single time. So enough to be within specification. And that bottom toe cap there, very similar. We started with a kit. Through heat and pressure, the part is formed into a toe cap. Okay, then we get into molding compounds. So again, talking about our skeletons that are left over from water jet, our tape that can be chopped, adding additional polymer. Then you can get into a very highly designed part. This is another example where we had a part that was a laid up kit. The parts had additional areas of reinforcement, and those areas provided a high level of detail, as you can see, receptacle for those, hardware to put this laptop together. The part was also injection overmolded. These are the markets that we serve. Medical orthopedic, this is what really launched our company. It's our pedigree. It's the foundation of literally everything else that we've done over the years. Consumer electronics, recreation. This is typically athletic footwear, skates, helmets, as you can imagine, anything protective. And industrial and automotive. So how do we like to work with our customers? Well, this is something that we at Toray like to use as an example, because it's something probably most people can relate to. I don't know how many of you have been in a 787, obviously not lately, but if you were in one, you would notice that those windows are much larger than our historical planes that we've flown in. Myself, when I got in, before I even worked for Toray, before they bought our company, you could just feel that the whole experience was more open. When you landed, you felt more rested. And this was because you were able to gain higher strength, so cabin pressure could be adjusted so that the body had less fatigue. The corrosion resistance, now it's made out of plastic and not metal, so the humidity could be, adjusted, that when you get off the plane, you don't feel like you've got to drink 10 gallons of water. And the optimized design, so quieter, able to talk without kind of screaming on the plane. So this is just one example, and how we work with most of the customers, that we develop long-lasting relationships. We dive in deep to your application. Naran, as I said, has been around the industry for many years, extensive experience in injection overmolding, and how your particular application can be achieved with continuous fiber reinforced thermoplastics, which is different from thermoset or a neat resin. It's really important. When we talk to customers, they'll have a part and they want to put maybe a lot of holes in it, or they want to have a undercuts and different design aspects that just are not compatible, but can be adopted into the materials that we work with. This is our global network. So now that we're part of Toray, we are part of a very large organization. And specifically during COVID, we found this to be so beneficial as we got to learn and meet some of our colleagues in other countries. We never missed a beat, so we never shut down. People talk about, oh, you know, we're getting back up to running. We never shut down. Our customers never went without product. And you can see the 3 PMC entities, which I will call out here on this next slide. We work and we are designed, set up in location exactly like our customers. So we have our design or our presence with our customers that are designing at the brands, you know, which could be anywhere over the world. But we have our manufacturing here in California and also in Guangzhou, China. We also have technical offices in Taichung and around the US and also in Europe. So we are everywhere our customers are. We work in that triangulation. We're able to respond very quickly, and we all work on a 24-hour clock. All right, with that, I'm going to open it up for, I guess, Q&A. We'll come back on video. You may have seen our internet here is not always the most stable, so sometimes the video can take away from that.
Okay, thanks very much, Laurie. Well, surprisingly, we have no questions as yet, but I have one question. I was wondering, we're seeing that thermoplastics, obviously, over the past few years are really making inroads now. How much are you seeing that your customers who may well have been using thermosets in the past are trying to move more towards thermoplastic?
Yeah, this is Nuran. I would say it's consistency and the high volume. We could make parts essentially at about 7 to 8 seconds a pair. So with net attributes, so you're dimensionally net as compared to a thermoset where you would typically have to go back and post trim. So that attracts a lot of people into the thermoplastics industry from thermosets.
Okay.
That's typically, and the cost of manufacture then all of a sudden becomes affordable.
Yeah, and you showed Laura at the end there the 787, which I have been in, and I concur. You do feel more rested, and it is quieter. Do you think we're going to see far more thermoplastics in that sort of use? Rather, I mean, what you showed were more, if you like sporting goods and things like that. Do you think we're going to go more towards the use in aerospace, for that matter?
It is growing. I think over the years, it's steadily grown into a lot of it. Again, you're back to cycle times. You're much faster cycle times. So that draws a lot of attention into, you know, converting over. So yes, I think it's happening. It's been happening for a while.
So have you considered then applying your thermoplastics to the likes of filament binding?
Yes, there are certain applications that they do. It's a heat process, but it can be like vessels, tanks, pipe wraps being done currently. In fact, there's been many applications using our unidirectional, actually the thermoplastic UD being wrapped into, you know, vessels and
okay, so you actually the UD being used as opposed to say a single, like a toe preg or something like that.
Correct. Yes.
Okay. So like in a cylinder, could I say that you might consider then using the UD to wrap the cylinder as a whole?
Yes. That's typically what they would do. Under heat, the resin would melt and fuse into the other layers that's being wrapped.
Okay, okay, good. Right. we've finally woken up. Balach asks, what is the maximum carbon fiber UD thickness with thermoplastic resin system you could achieve?
Yeah, you could just apply. It's again, my example I always use is plywood. Plywood has the wood veneers, and you could just keep piling the wood veneers till you get the needed stiffness. So essentially, unidirectional tape that is typically used with the resin impregnated would be similar to that process. And it's directional, so you could layer the plies accordingly to get the stiffness directions and the distribution or isotropic properties that you're looking for in a structure.
Okay.
Getting to do it, right?
Yeah.
It's going to take some pretty big equipment.
Yeah. Yes, I can imagine. Yes. Young Ho Choi from Hyundai asks, as a carbon fiber manufacturer, are you using different sizing or different polymer grade CFRT?
You mean in the fiber itself, the sizing?
I think that's what he means, yes.
Yes, we typically work with sizings that are compatible with certain types of polymers we use. So it's, again, not necessarily a particular type, but it's usually epoxy compatible. Certain epoxies, sizings that work with epoxies work with our polymers.
Okay.
But certain sizings don't. So yes, there's some sizings that are not compatible.
Okay. And Gherkin from SARM has a question for you, Laurie. Since you are the marketing and sales director, what do you think in the future the market share of Toray will stay the same or reduce, since we have now many newcomers and every CF producer are investing for expansion? So basically,
so we're in a lot of different markets. So it's a little bit of a trick question. I would say that as a company, Toray is dominant in any market that they enter, and that's their intention, and that's what we work to do. So we don't last long here if we're not dominant.
Very, very true. Very true.
And if somebody wants help, we're there to support it to grow their business as well. So.
Okay. Right. And I must go back to the old chestnut, which is obviously the recyclability of a thermoplastic is much easier than a thermoset. Is that some of the things that your customers are considering when they're choosing thermoplastic?
Absolutely. Sustainability is such a big part of our conversation with all of our customers. Yeah, absolutely. It's particularly in the consumer area. I think that there's just, there's a huge movement. We were all seeing it, right? It's the sustainability. So it's a must. It used to be something that, we should be thinking about. Now, our customers really don't even want to talk to us unless we've got some end use for our crap. Absolutely.
Yeah, I think I know from my own experience that people, when I was in the recycling industry, the companies used to approach me and say that before they could win a contract, they had to have a route to recycling. Otherwise, they would not win the contract. So that was back in 2008. I think now, we're going to see that again, because obviously, judging by the discussions we've had today, we're going to see that desire to close that loop as much as possible. And to make it easier, if using thermoplastic is the better way to go, then obviously that's what's going to happen. Yeah,
absolutely. I think more and more we're seeing customers offer products that are completely of recycled materials. If you look into the marketplace, I can't think of a market that we're in that it's not part of the conversation of how do we get there, at least if we're not already with their products.
Okay. That's good. That's good. Well, thank you very much, both. That was very interesting. It was good to hear from you, and I wish you all the success.
Thank you, John.
Thank you for your help.
Thank you, Glenn.
Okay, no problem.